So now we are going to discuss about the Turing machines. So in general, we will design a finite automata in which we will read from left to right. Q0 on reading symbol 0, moving to the state Q1, and Q1 on reading to symbol 0, going to Q2. So like that we can't come back what the state Q0 has been read. So if you want to know what it has been read or not, we have used a special data structure called stack to remember what was read, right? So that is that type of finite automata, we will be calling it as push down automata. So there exists some other type of abstract machines, designing of that abstract machines called Turing machines. The time when we are going to read the data, the same meanwhile we are writing it the same data into the tape. Okay, reading 0, writing into it, reading 0, writing into it, reading 1, writing into it. So like that, the time when we are reading only, the data will be written, and then we are moving from one state to the another state. We will be calling that type of automata as designing of that type of automata as Turing machines. Okay, so Turing machines have, it is works as same like finite automata. The only difference is we have a toe symbol and B. So here in the Turing machine we are using a tape in order to write the data into the tape. What was read, that should be written into the tape. So in the tape, whatever the symbols that are existing in the tape, we will call that as the toe. Toe represents set of tape alphabets. And B, here B represents the blank symbol, saying that starting of tape and ending of tape. And there will be a read write header like a pointer pointing from start symbol to the ending symbol. It will be keep on moving from left to right and from right to left. Okay, so now we will discuss about the definition of Turing machine, which consists Q. Q means it is finite set of states. Sigma is set of input symbols, and toe is the set of tape symbols or tape alphabets. Means whatever the input symbols we are placing, writing into the tape, we will be calling it as tape alphabet. And delta. Delta is a transition function, how we are doing for finite automata in the same way. And Q0 represents the initial state. B represents the B represents the blank symbol that is present in the tape, representing the starting and ending of the tape. Okay, and F is the final state. So Turing machine is represented with the 7 tuple notation, same like stack. And here the difference is we are using toe as the tape symbol and B as the blank symbol. Okay, other than that the rest will be same. Okay, so now we are going to learn about the simple model to design a Turing machine. Okay, now let me start here. Okay, for a language, capital L equals to 0 power n, 1 power n, such that n should be greater than or equals to 1. This is our language. We have designed the push down automata, right? Now we are going to design the Turing machine. So how to design a Turing machine? What are the possible strings we will get for this? Might be 2 zeros and 2 ones, or 3 zeros or 3 ones, or any equal number of zeros should be followed by equal number of ones. That is the question. So I will take this as an example and try to design a Turing machine based on this. Okay. So in a tape, it should start from the zeros and ones, right? I should read and write. So when I read when I read 0, it should be replaced with x. Why it should be replaced with x? Because saying that I have read the 0 and written it as x. Okay, so in the same way, 1 0 has been read means according to our language there should be 1 0 means there should be 1 1. 2 zeros means 2 ones. So I have read 1 0. So we are just moving the tape, that is the header, moving just header to right hand side until unless I get 1. So I have read 0 and written it as x. And when I read 0, just replace with 0 0 because I should get 1. Until that the tape will be moving to right. When I read 1, then that will be replaced with y. So once it is done, then we are not reading this one still. We are not reading, not writing. Once it is read means we should write it. So 1 is replaced with y. then move the tape to left. So left we are moving means 0, 0 and x. So whenever we reach x, then the header should move to right. Okay, so this 0 will be replaced with x. Again the tape will be moving. Whenever it reach 1, it will be replaced with y. See, by seeing this we can tell that 1x, 1y, 2x, 2y. So whenever I have replaced y with 1 with y, the tape should move to left, moving towards this. When it reaches x, then move to right. Then when we read 0, it will be replaced with x. Then y is replaced with y, y is replaced with y. Whenever I see 1, it is replaced with y. So now all zeros or ones are replaced with x and y. Once again I will repeat. See, if we take the string 0, 0, 0, 1, 1, 1, whenever I read 1, then I should check for, whenever I read 0, I should check for 1. Whenever I read another 0, then I should check for another 1. Whenever I read 0, 0 is replaced with x. And in the same way, 1 is replaced with y. So the tape, what it does, it will read 0, replace 0 with x. And then whenever I see zeros, read 0, replacing 0 with 0 only, because I don't want to write 0. I want to write 1. Whenever I read 0, then I should read 1 and write 1. So x 0, 0, 1 is replaced with y. Then move the pointer to left. And then it will be reading until we will get x. Then move to right. Then 0, replace with x, move to right. When I get 1, replace 1 with y. Then 1, replace 1 with y. Okay, then move to left, 0. Replace 0 with x. Then move to right, replace 1 with y. Okay, 0, red, right, written. Then just move. I got 1, red, written. Then move left. X I move right. And 0 is replaced with x. Then just move. When I get 1, replace 1 with y. Then move left. Replace the 0 with x. Then move right, replace 1 with y. In this way, I should model the Turing machine. So I will write a transition function first, like PDA, and then we will see the transitions. Delta of always start with Q naught on reading 0. On reading 0, what we have done? Replaced 0 with x. Q naught on reading 0. It will be in the, means we are writing it, so change the state to q1. Q1, replace 0 with x. So we have written x. We are moving to which direction? To right. So we should write r. Okay. Next, after reading 0 and writing, we are just moving to right. Whenever I see 0, q1 on 0, going to same state. Right. It is not changing 0 to anything else here. We are just moving. So is replaced with 0 only and moving to right. Any zeros you will get, just read it and move to right. Any number of zeros, just read it and move to right. So whenever I see 1, so delta of q1 on 1, whenever I see 1, then replace that with y and state will change. So q2, 1 is replaced with y. So replace y. And so once this is done, we should move to left because I should check for 0. So once it has been replaced with y, then we should move to left. Okay, 1x and 1y is done. That's why move to left to find 0. So here we should write L. L means left, R means right. Okay, now delta of Q2. Q2, we have moved left. I got 0. So Q2 on 0, it will be in the same state. Q2 on 0, just write 0 only and move to left. So Q2 on 0, replace 0 with 0, move to left. Q2 on 0, replace 0 with 0, move to left. When I get x, so when I get x, what we will do? Q2 on X. We will change the state to start state because we have reached X. So Q0, replace X with X and move to right. Means replace, when I reach X, replace X with X only and move to right. Then not on 0, again silver, not on 0, Q1. So like this it will happen. So next what happened? Q1 on 0 is, I have read Q1. Q1 on Q0 on 0. Sorry, Q0 on 0 is because we have replaced Q1 to Q0 and move to right. So Q0 on 0. Q0 on 0 is Q1x. It means replacing x with x and moving to right. Now Q1 on 0. So we have 0 here. Q1 on 0. It is going to Q1 0R. So I want one more transition. That is Q0. Q0 on 0 is Q1XR. Q1 means replacing this 0 with X. Okay, same transition. Q0 on reading 0, replace that with X and Q1. So that's what we have done. Replace 0 with X and moving to state Q1. Next Q1 on 0. Q1 on 0 is just replacing 0 with 0 and move to right. Okay, replacing 0 with 0 and move to right. So whenever I see Y, means the state now I am in Q1. Q1 on Y. So I haven't written any transition with Q1 on Y. So write it here. Delta of Q1 on Y. So Q1 on Y should read it and Y should be placed as it is. So Q1 Y move to right. Because Q1 on reading Y, replace Y with Y only, replace Y with Y only and move to right. When I get 1, Q1 on 1. When I get Q1 on 1, replace 1 with Y and move to left. So replace 1 with Y and move to left. So now the state is Q1 only. Sorry, the state is Q2. So Q2, delta of Q2, again if I read Y, with Q2 on Y we don't have transition. See Q2 on Y. So here we have moved left. Q2 on Y, replace Y with Y only. So Q2 Y moving to left.